So today we're going to cover Chapter 5, Section 2. Today we are going to be covering congruent polygons. So the first thing we're going to do is define what a congruent figure is. And a congruent figure is just two figures that have the same size and shape. All of the corresponding parts of one figure are going to be congruent to the corresponding parts of the other figure. So when you're trying to show if two figures are congruent, we need to match every single angle and every single side. So when there are two triangles, we're going to have three corresponding angle parts that will be congruent and three corresponding sides that will be congruent. So I'm going to go ahead and go through these two pictures and I'm going to show you all of the corresponding parts. And notice the angles have been color coded for you. Notice angle A and angle F are both written in red. So I'm looking for three corresponding congruent angles or angle pairs. So the first one is in red. It's angle A is congruent to angle F. Notice they both have the single congruency mark. Then in blue, I've got angle B congruent to angle E. So that would be my next statement. Angle B is congruent to angle E. And then my last one is the green. So I can see here that C has three marks and so does D. So I would state that angle C, do it in black so it shows up, angle C is congruent to angle D. And that were the green letters. Now I also need to look for the three corresponding side lengths. And again, I'm looking at the congruency marks. So far I've matched the three angles. Now I'm going to look for three corresponding side lengths. So three corresponding sides that are congruent. So I'm going to look at the markings. So notice over here where I'm going from A to B, that's got the single mark. And same thing here from F to E. So that'll be my first statement that AB is congruent to FE. They both have the same markings. And then if I look over here, and again, it doesn't matter the order that you look at the markings. I'll go from the double mark here, A to C, and F to D has the same marking. So I'll show that AC is congruent to FD. They both have the same congruency mark. And then lastly, BC has the triple, and so does ED. So BC congruent to ED. I've now found all six congruent corresponding parts. So I can say that these two triangles are congruent. Now, once you're able to match all six pieces, you're going to be able to write a final congruency statement. So I can finally say that triangle ABC is congruent, and the order here matters, to triangle FED. And notice what I can do to get this statement is I could look at what I just listed for the angles, and I can go in the same order that I listed them. So notice I went straight down ABC, and then I matched it with the FED. If you're only ever given a statement like this, we can use this to create our own picture and then add in the congruency marks. So for example, notice the first letter here, letter A, is going to match with the first letter in the second triangle. So these two angles would be congruent, which is the statement I put over there in red. And then the blue ones, that was the B and the E. And notice they're the second letter in the statement. And then lastly, the green one, and that was going from C to D, and that would be the third congruent angle pair. So this congruency statement is very helpful when you're trying to figure out what angle is going to match. Because sometimes the two triangles or the two figures are not sitting the same way. So by using this statement, you'll be able to see which angle matches where, or which side length. I could also use to match the sides. So for example, notice the first two letters here, AB, they're going to match with the first two letters here, the FE, which was what this statement right here was. And then if you look at the AC, that's the first and the last letter, and it's going to match with the first and the last letter here, which was this statement. And then finally, these two, the BC, the second and the third letter, match with the second and the third letter here, which was this statement. So by just being given this, we can find all of the 6 corresponding parts. Okay, the theorem is called the third angles theorem, and this one states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Now, when you're writing this in a reason as a proof or writing it down if you want to abbreviate it, you could abbreviate the word third and just put the number 3. And then angles, you could put the little symbol, and then you could abbreviate theorem as THM. So let me show you what this means. So if I give you that angle A is congruent to angle D, and if I told you that angle B was congruent to E, then automatically by default, angle C is going to be congruent to angle F. Let me go ahead and add in some numbers so you can see this a little bit more clearly. So for example, let's say I told you that angle A was 20 and angle B, let's say it's 100. And last week, we learned the triangle sum theorem. So I know that I can take 20 plus 100, add that, and then subtract it from 180 to get my missing angle C, which would be 60 degrees. So now if I take these same numbers, because A was congruent to D, because it had the same marking, D is also 20, E is congruent to B, so this one's also 100, and I could do the same math or just realize that C and F are congruent, so F would also be 60 degrees. So once you know 2 of the angles in a figure, you can find the missing third one by adding and subtracting from 180. And know that if you have 2 pictures of 2 triangles, and if they've already got 2 congruent angle pairs, then automatically that last third one would also be congruent. So now we have properties of congruent triangles. We've got the reflexive, the symmetric, and the transitive. We've already seen all of these properties for variables, for angles, for segments, and now we're applying them to triangles. So here, the reflexive property of congruent triangles, this just states that triangle ABC is congruent to triangle ABC. Any figure is always congruent to itself. Then the symmetric property, this is where the order switches. So if ABC is congruent to DEF, then DEF is congruent to ABC. And then lastly, the transitive property, if ABC is congruent to DEF, And if DEF is congruent to JKL, then ABC is also congruent to JKL. So remember, for the transitive property, this middle part cancels out, and then you can go by saying that this first triangle is also congruent to the last one. And that's your transitive property. And now let's do some examples. All right, so for example 1, they want us to fill in the blank line with the words sometimes, always, or never. So I know my blank line is a little small. So for the answers that are always, I'm going to put a capital A. For sometimes, I'm going to put a capital S. And for the never answers, I'm going to put a capital N. So the first question, an acute triangle is sometimes, always, or never congruent to an obtuse triangle. And this would be never. Because remember, an acute triangle needs 3 acute angles. So if it needs all 3 acute angles, it can't have an obtuse, so it would never be congruent to an obtuse triangle. The next one, a polygon is sometimes, always, or never congruent to itself. What do you think? Always, good. And the next one, a right triangle is sometimes, always, or never congruent to another right triangle.
Always. Sometimes?
Sometimes. Good. All right, so watch. Let me draw 2 right triangles for you. Now, we just saw that in order for 2 triangles to be congruent to each other, they would need to have all of the same angle measures. So let's say, of course, they both have a right angle, but let's say this one is 30 and this one has a 60-degree angle, but I could have another one, they're still going to add up to be 180, but now they're not congruent. Now, if I would have given you 2 45/45s, that would be the case when they would be congruent. These 2 are congruent, but this one is not congruent to that one because it does not have all 3 angle pairs being congruent. So that's why it's sometimes. And then the next one, if ABC triangle is congruent to XYZ, then angle A is sometimes, always, or never congruent to Y.
Sometimes.
Beautiful. Sometimes. So look at this. So remember how I told you that this statement, ABC congruent to XYZ, remember I told you A and X would match, and then B and Y are supposed to match, and then C and Z. But this one said A and Y. So the case where it would be congruent could be like what I just drew here. Let's say this is A, B, C, and this is X, Y, Z. So in the case of the isosceles triangle, A could be the same measure as Y, but it will always be the same measure as X. So the last question is always, because notice A is in the first spot and so is X. But A would be congruent to Y if we're talking isosceles. Example 2 wants us to find the value of X and Y. So again, what's going to be key is going to be that congruency statement they gave me at the beginning. So I can see that the first letter A is going to match with F. Then the B is going to match with the G. The C with the H. And then lastly, I can match the D with the K. So now I'm going to look to see where is X and where is Y. So I can see over here on my side length GF, I have 3x minus 6 is the length of GF. If I go back to my statement, notice G and F are the first 2 letters over here. So I'm going to match it with the first 2 letters in my ABCD. So I can see that GF is going to match with the BA. This is going to be the equation I'm going to set up to solve. So I can state that GF or FG is congruent to BA or AB. And FG was the 3x minus 6. And AB was the 9. So I'm going to go ahead and solve for x by adding 6. Okay, so 3x equals 15, divide by 3, and x equals 5. Now we need to work on solving for y. All right, so here is where I can see that I have y. It's 4x plus 2y, and that's the value of k. So if I go back up to my statement, I see k is my last letter. So it's going to match with the last letter over here, which is going to be angle D. So this will be the equation that I use to solve. I'm going to set angle K equal to angle D, and angle K was 4x plus 2y, and I set that equal to D, which is 44. I now need to solve for y. I'm going to use my newly found value of x and plug it in. So 4 times 5 plus 2y equals 44. I'm going to multiply. Going to subtract. I get 24, divide, and y equals 12. So x is 5 and y is 12. Two triangles are congruent is by showing that all three angles are congruent in both triangles, that they have a corresponding congruent pair, and that all three sides have a corresponding congruent pair. So let's go ahead and do the obvious first. Let's work on the side lengths. So notice over here, I've got a congruency mark on SV and then also one on TU. So I'm going to show my three congruent side pairs first. Okay, so the three congruent side pairs first. So the first one I'm going to show is that SV is congruent to UT. And then I also have a congruency mark over here, ST and UV. So I can also say that ST is congruent to UV. And then the one that isn't marked, but is shared by both triangles, is this one down the middle, SU. SU is the same side in both triangles, so I'm going to use my reflexive property and state that SU is congruent to SU. So I've now shown that both triangles have a congruent corresponding match. Now I have to do the same thing for all the angle measures. So now I'm going to find three angles, three congruent angle pairs. I'm going to do the obvious, the two right angles. So I can show that angle V is congruent to angle T, because all right angles are congruent. Now, to get the other one in here, I can see that I have parallel lines, and by showing that since these two lines are both perpendicular to the same line, then they're parallel. So I can show that ST and UV are parallel because they're both perpendicular to the same line. They're both perpendicular to SV, or they're both perpendicular to TU. It really doesn't matter because I got right angles on both. And then this will be my transversal. So I can show that angle 1 is congruent to angle 4 because they're alternate interior angles. And then I can also show that angle 2 is congruent to angle 3 because they're also alternate interior angles. Because I showed that ST was parallel to UV because they were both perpendicular to the same line. So now that I've shown that all three angles have a corresponding congruent pair or part, I can say yes, these two triangles have the same size and shape because they are congruent triangles. They are congruent triangles. I've shown all 6 pieces have a corresponding congruent match. And then the last one is a proof. So the last example wants us to write a proof. They want us to prove that triangle STV here, this one right here, is congruent to triangle RWV. Now, they've given me quite a bit of given. So I'm going to go ahead and set up my 2 columns. I have my statement column and my reasons. I'm going to state all this given, and then I'm also going to mark it in the picture. So they gave me that SV is congruent to RV. They also gave me that TV is congruent to WV, and that ST is congruent to RW, and this little angle mark here should be in front of the T. Angle T is congruent to angle W. So this was all given. So let me add in the markings in the picture. So SV congruent to RV and TV congruent to WV and ST congruent to RW. Then they also told me that angle T was congruent to angle W. So notice in my picture, all I need to come up with are the other 2 corresponding congruent angle pairs. And I'm going to pull my obvious. This looks like my bow tie. And I can do the vertical angles here and show that this angle is congruent to this. I can't just call it angle V. I need to name it with 3 letters. So I'm going to name that angle as TVS. So angle TVS is congruent to angle WVR. And this is using my vertical angles congruence theorem. And my abbreviation for that is VAT. And now I just taught you a new theorem, which was called the third angles theorem. So if you already have 2 congruent angle pairs between your 2 triangles, then automatically that last third angle pair will also be congruent. So my last statement will be that angle S is congruent to angle R, and my reason is that third angles theorem. So I'll add in the markings, 1, 2, 3, 1, 2, 3. So now notice in your picture, all 3 angles have a congruency mark on them and all 3 sides. So I have now proven that triangle STV is congruent to triangle RWV. And the reason is definition of congruent triangles. In the homework, you need to show the work for numbers 4, 5, 7, 8, and 9. One of them they're asking you to write a proof. I want to see you handwrite the proof. I know you're dragging and dropping, but again, practice writing the proofs. So these are the ones you're showing work for. Some of the other ones are just vocab, so you don't have to show work for them.